All right. Just testing this, testing the sound. Okay, I'm not sure if I'm gonna. Yeah, testing the sound. Testing the sound. Okay, I can't figure out whether people can hear me or not. If you cannot hear me, hello. If you cannot hear me on Discord, please let me know. Well, please let me know on Discord if you cannot hear me on YouTube. Hi. Okay, hi everyone. There's chocolate. Feel free to help yourself. The people who are not here, this is what you're missing. You could like, cool. You could be like me and go to Walmart. Those are $10 there, so
That's cheap.
that is cheap. Yeah, it's probably made of plastic, but. Hello. I have bought 4 of them, so there's probably going to be some left for next time, like 4 boxes.
I think they can hear you.
If no, I think they said they could. Yeah, I will leave some in my office. If you're really feeling like you're missing out, you can come to my office in September for office hours. I'll give you some chocolate. Okay. Yeah, so we'll wait like 2 more minutes. And then we'll start. Yeah, I'm waiting until it says 7:31. Yeah. Okay. So there is now a course website. So so most people don't really. Most of your professors will post courses on Quarkus. I prefer to use my own thing. You can preview last year's 180 and 190 if you like. If you just go to my webpage, it's all linked here. And usually, like, you would also see last year's TAs, stuff like that. The mini course is DS 101. Our TA is going to be ChatGPT. I'm kind of excited about this. I kind of made something. We'll see if it works or not, but I'm kind of excited about the possibilities there. So what I want to do today is kind of review functions a little bit. For the people here who do have programming experience, I hope you'll get something new out of it, because we're really going to kind of do kind of the algebraic approach to understanding functions, and you'll see what I mean. And we'll then do function stepping, and we'll talk a little bit about how to use ChatGPT to help learn about functions. I think it's kind of fun. Like, if you know about functions, maybe it's not by itself going to be useful, but I think it's a useful way to look at the capabilities of ChatGPT. So we'll discuss that a little bit. And then we'll do a little bit about vectors, data frames, and so on, if there's time. So I want to, again, kind of review the idea of what a function is. So very quickly, in math, you can write something like f of x is x squared plus 1. right? And then when you compute something like f of 5, what do? Well, you substitute 5 into the formula, and you get like 5 squared plus 1, so that's 26. So in R, this is basically saying the same thing. There is a bit of a nuance there, which I will not get into during this mini course, but we will see a lot of it later on in ESC 180. But basically, at least for the purposes of this mini course, this and this are just the same, right? So this is just a way of writing this. So if you're just starting out with programming, like I mentioned before, it's a bit of a switch to a situation where if you don't get the syntax exactly correct, it just won't work. So syntax comes from linguistics originally. So the rules according to which sentences are constructed in language. For example, I can say like I ate lunch, and the rules for English say that I have to say I ate lunch. I cannot say lunch I ate or something, right? So in English, that's just not allowed. Like maybe you can understand what it means, but in general in English it's not allowed. In some other languages, you might imagine that you would say something like that, but it would mean that the lunch ate you, not that you ate the lunch, right? So in English it doesn't work like that. In other languages, that is how it would go. So the rules that govern how you get to combine words and how you don't get to combine words are syntax. So the syntax in R says, okay, so you have the little left pointing arrow, and that means take whatever is on the right hand side and stick it in the left hand side. So in this case, we're saying this is going to be put in F. The syntax rules also say that if you have function is a special keyword. So if you say function, that means that you're defining a function. And then you can have a parameter or multiple parameters inside. Those parameters are going to be in round parentheses. This would be referred to as the body of the function. The body of the function must be enclosed in curly braces. And then the value that the function computes, well, you can just write it there. So someone asked, like, do you not have to do return? Well, in R, no, you don't. In other languages, yes. So this is not like a lot of rules. There's like several dozen, so like it's not an amazingly large amount. At the same time, if you're just starting out, it's probably a lot to take in. So what I would recommend is that you just kind of follow the examples here, and then if you want to write something new, like you want to write a function that computes square or something, well, take something that works, copy it, paste it, and then change it to whatever you want. So for example, change this to say that this is now a function that's named square, and that computes x squared when you give it x. Okay. So in general, so here I would try to run it. So that ran, and if I tell it to print it, then it will print 25. So often you might get something wrong, right? So you might imagine that you say something like x squared minus by mistake. So if that happens and you run it, so what I did is I pressed source, you'll get, well, R is going to yell at you in some way. And sometimes it's going to be informative, sometimes not, right? So usually it will tell you which line is causing the problem. So here it correctly identified that the problem with the syntax is in line 20. And then usually you would just go and look and see, okay, what doesn't make sense here? Here you'll see, oh, well, I put the minus here, so that's the problem. Of course, if I said like -1, it wouldn't be square, but it wouldn't be a syntax error. right? So there is a distinction, just like in English. Like you can say something that follows the rules of syntax. So like I ate brick follows the rules of syntax. It just doesn't make sense. Or, well, that could make sense. Or like I ate, I don't know, something abstract. I ate ideology. Well, that doesn't make sense at all because like that's not even like a thing that you could even try to eat, unlike bricks, which you could try to eat, right? So in general, so this would be kind of in linguistics terms, if you like. This is not really computer science, but you would say, okay, like this is not really square, so that's a problem with semantics. That's a problem with what the thing means. But it's not a problem with syntax in the sense that as far as the rules about how you can combine things, it's completely fine. In fact, you run it, it works, just maybe it won't compute what you mean it to compute. Okay. So the more you experience this, I think it's basically about practice to kind of understand this kind of more in depth. You just need to try to write stuff. And I will be posting exercises very soon, so you'll get a chance to do that. So, okay. So, another thing that you can do is something like that. So I'll define a function. And this is a little bit not like math, so this is something that we already saw before, and maybe it completely made sense to you, so you didn't even need to think about it. But this is not exactly the kind of thing that you have in math, but this is something that you can do, right? So what is this saying? This is saying, if I do h of 10, well, if I want to compute what h of 10 means, well, eventually it's going to be this, but this is not defined before you figure out what y means, right? So what this is, the way we're going to understand this in this class, and it's going to be a little bit different from maybe what you're experienced with or what you'll see in the fall, is this is, again, just algebra. So this, we think about it as just scratch work. So sometimes you have a complicated expression, 2x not really complicated, and you're just saying, okay, I'll just kind of, whenever I say y, what I really mean is 2 times x. And that's all it is. So it's still algebra, but it's kind of a stepwise thing, right? So this is something that you're probably kind of a little bit familiar with in math, right? So again, going back to the square roots example, the square root is like minus b plus or minus, so this is not r, square root of the discriminant divided by 2a, right? So how do you compute it? Well, it's a formula, but there is a discriminant there, and the discriminant is just whatever, so b squared minus 2ac, right? So how do you plug it in? Well, like it's still a formula, it's just that there is like a sub-formula inside there that's defined as you go. So if we want to compute the square roots, we did this example again, but I think it's worth revisiting. I'll just preview something very quickly. So in R, you can put two things in the same variable. So I can say C, something like that, and that would be what's called a vector. So it's just not one element, but several elements just stuck together. And you can do it using C. So someone asked during a lecture the other day what cat means. And I think someone actually said concatenate, and I said, I'm not sure it is. It is concatenate. So there is an interesting history to it. So back in the 70s, people just were starting doing computers that were printing stuff, and concatenate meant like you're outputting the text. I want to concatenate whatever new thing is to the output. Concatenate just means put together. So that is where cat comes from, and in R it kind of got carried over. So the C here maybe inconveniently also means concatenate. So this is saying concatenate 5, 6, 7. Yeah.
Can you access the vector study?
Yeah, you can. So we'll do it kind of in so you can. So for example, this is 6. So we'll do it kind of in more detail later on today. Actually, I just wanted to do the square root, and because sometimes there's 2, I need to have a way to concatenate, right? So I'll do that. So that'll take A, B, and C. So here I'm using capital letters. The reason I'm using capital letters is because if I can use C lowercase as a parameter, except that would interfere with my using C for concatenate. So I won't do that. And here what I'll do is I'll compute so it will compute the discriminant, but I'm not thinking about it like that. I'm just thinking about whenever I say the discriminant, I mean b squared minus 4ac. Like this. And now we have 3 cases, right? So discriminant is greater than 0, equal to 0, smaller than 0. So we'll just do, so if discriminant is greater than 0, then we have 2 roots. So I'll return the 2 roots. So the way I'll do it is I'll compute one. So not compute, I'll say whenever I say R1, what I mean is minus b minus square root of the discriminant divided by 2 times a. And R2 would be the same thing except with a plus. And now the value is going to be R1, R2. So, by the way, a lot of the time people kind of complain, oh, you're typing too fast. You guys should spend August learning to type fast too. So one thing that's particularly I find useful, so you noticed that I selected this and then I copy and pasted this, and it was very fast because I wasn't using a mouse. So the way you do it is you put the cursor wherever you want. So I use just the arrows in order to find where I want the cursor. So on Windows, I press Shift and End, and that selects the entire thing. Then I do Control C. Then I go with my cursor wherever I want, and I paste it. Takes a little bit of practice, but like a lot less practice than what you needed in order to get into EngSci. So get on it. So on a Mac, unfortunately, it's 3 keys, which I don't remember, but you can look it up. So in order to select the entire line on Windows, it's Shift, and then you press the End key. Or if you are at the end of the line, you can press Shift Home, and that'll select to the left. So it's the End key and the Home key. On Mac, I think it's like Mac Control Left, Mac Control Right, but I might be wrong. So someone on Discord, please tell us how to do it on the Mac.
Which key is end?
So on the Mac, there isn't an end. And it says End. So it's usually in the top right.
I have Mac keyboard, bro. You need Windows keyboard. He has Mac keyboard, but Windows iOS.
So that's interesting. Okay.
Command is control.
So back to the square roots. And we'll go over it again in a second. So if the discriminant is 0, then there is just 1 root. And that would be, like, it's the same formula, except discriminant is 0, so you don't need square root of 0, right? So it's just minus b divided by 2a. And else, there are no roots, so I'll just say C like this. So C like this would be, so here it displays as null, so this would be the empty vector. It doesn't have anything. Okay. So, all right. So I want to look at this function and think about it as if it's just a complicated formula, which in practice it is. So for the upper years who are in this course, who are thinking, no, that's not a formula because first you compute R1 and then you compute R2 and then you make this vector R1, R2, well, kind of, but not necessarily. So in fact, in R, not in this situation, but sometimes R does do what's called delayed evaluation. So that means that you might think, if you have programming background, that no, like you definitely got to compute R1 when you say put minus b blah, blah, blah into R1. The answer is, well, no, not always. You can do delayed evaluation. So Google it if you're interested. That's advanced material. So we're not thinking about it. We're just thinking about this as if it's a math formula. So what does it mean? So it means that if I'm computing, for example, square roots of 1 to 1, right? So that means that I'm thinking about the quadratic equation like x squared plus 2x plus 1 is equal to 0, right? And that's, as it happens, that's the same as x plus 1 squared is equal to 0, right? That's the same. So that has one root, which is minus 1, right? So that means that the output that I expect here is minus 1. Make sense? So here's how I think about how the computation happens. So I'm saying square root 1 to 1. So that's the same as taking this and then just substituting 1 to 1 into this entire thing. So what I'm doing is I'm copying this, and I'm just expanding the formula the same way that you would do in algebra. So here I'm substituting 1 to 1, so b is 1, so b is actually 2, a is 1, c is 1. And then discriminant, well, we'll find out next time. Here we need the discriminant, can compute this yet, can compute this yet, no R1, no R1, no R2, can compute this, can compute this. This is just the empty list, vector, sorry. So the next step would be just keep going and just keep simplifying the expression like you would with algebra. So I'm copying this again. And now the only thing that they, so I didn't actually substitute everything here. So here B is 2 and A is 1. A is 1, B is 2. So that we got to do. This is 2, this is 1. So now I'll copy this, and now I'll again substitute whatever I can. So here, that's just numbers, so I can compute that. So this is 4 minus 4, so that would be a 0. So next time we'll be able to substitute the discriminant. Here, 2 times 1 is just 2. 2 times 1 is just 2. 2 times 2 divided by 2 times 1 is minus 1. So now next time I get to again compute whatever I can. So disk is now 0. So now that's not necessary because now I know the disk is 0. So I'll just substitute 0 instead of disk everywhere. So now I have this, and I did not, so here I had an R, which I left out. So now that's going to be like this. So now I again get to do all my substitutions. So disk is 0, disk is 0, disk is 0, disk is 0. So now I get to compute the next step. So if you remember, expressions like 0 greater than 0 actually have a value, right? So the value is true. So this is true. This we got to compute. So this is minus 2 divided by, this is minus 2 divided by 2, so this is minus 1. It's also minus 2 divided by 2, so that's also minus 1. So next time we'd be, this was actually false, I'm sorry. So this though is true. 0 equals 0 is true. So now we have R go, so R will be able to substitute next time. So next time this will just be minus 1. So we do one more step. And now we don't need this, so this would be C minus 1 minus 1. This would be minus 1. This is null. And then the value of this thing, here we're saying if false, else if true. So the one that you pick in order to evaluate this expression is just the thing that corresponds to the option that's true. So that means that the value of this is a formula. It doesn't look like the usual math formula, but it's still a formula. It just says, like, wherever it's true, pick that one. So that means that what we end up doing is saying minus 1. So the value here is minus 1. Right? And again, I want to emphasize, this is like applying the quadratic equation, right? So you have a formula, you plug stuff in, and then you do step by step, just simplify it until you get your answer. And that's exactly what's going on here. All right? And this might be more intuitive for people who don't have programming experience, but this thing really is a formula. It has a value. The value is minus 1. Right? Why is the value minus 1? Well, that's the syntax. So the value of this formula is whatever is inside the braces where the condition is true. Okay? And the whole thing was substitution, right? So we started saying square root 1 to 1, then we put 1 in here, 2 in here, 1 in here, and we just said whatever is the value here, when you plug in A equals 1, B equals 2, C equals 1, that's the output. Right? So, okay. So that's like that. I think it's useful to have some practice with that. So I'll show you the thing that I set up for ChatGPT. So this is at this link. So you could just look at my conversation with ChatGPT for tracing another thing. So I imagine that probably everyone kind of experimented with ChatGPT. I don't know kind of in how much depth. So one thing to know about ChatGPT is that you can talk to it like you're talking to a person, just shooting the shit, but you can also actually kind of guide it towards answering in a way that makes sense. So here what I did was say, okay, I want to be able to give you a possible, this is called a stepping process for R. And I'm going to give you an example where it was done right, and I'm going to give you an example where it was done wrong. And now I'm going to give you what I came up with for a problem that I'm solving currently, and I want feedback on that. So this is kind of the entire thing that they said, right? So here's an example, and there's various ways of doing it, right? It's not just the one way. I'm just having my own thing that I made up. So I'm saying here's an example. So for my abs from last time, if I'm trying to step through my abs minus 5, well, that means that I'm substituting minus 5 into this chunk. And so I'm substituting. So now I'll evaluate this expression. Is 5 greater or equal than 0? No, minus 5, sorry, greater or equal than 0? No, it's not. So that means that this is just false. So this is if false minus 5, else 5. The value of this is 5 because you pick the option which corresponds to whatever is true, or if nothing else works, you go to the else clause. So the value of this formula is 5. So that's what we have. So now I have my square roots example here. And here I kind of suggest, so this one is a little bit different because here I made it print error if there are no roots, depending on what you need. Like maybe sometimes instead of saying, like here's a null, like if there's no roots, like the thing that makes sense to say is there is no roots, not here are the roots. Oh, by the way, it's nothing, right? Although in a computer sciencey way, I guess kind of it's more usual to say here are your roots. As it happens, the thing I gave you doesn't have anything. Okay. So here I kind of intentionally made a mistake. So I said, okay, like so we'll do here, and then we're here, but here I just directly said this. So I kind of forgot that this is also a value that also needs to be evaluated before I get to officially say it's minus 1. And here I'm saying like this is almost right, except I missed this, so this is what I wanted. So this technique of interacting with ChatGPT is called prompting. So basically, if I hadn't given it this example and I tried it, then it wouldn't catch errors. So here I'm kind of telling it, okay, like when you're giving me feedback, be as picky as I am when I'm giving you the examples. And that sometimes gets it to do it. So here I'm having, here what I did is I said, okay, I'll do another example. So it was like today, so I did like an example about like exceptionally hot and exceptionally cold days. So here's the function. So this one takes 2 parameters, so current temperature and the average temperature for the day. And then I'm saying if the absolute difference between the current temperature and the average temperature for the day is more than 10, then it's either exceptionally hot or exceptionally cold, right? And that's what I'm doing. So I'm saying if that's the case, then this is going to be the value. It's going to be either exceptionally hot or exceptionally cold, depending on whether the current temperature is greater or is smaller than the average temperature. It's probably not the most elegant way in which you could do this, but it's a way. And then if this is not the case, so if the absolute difference between the current temperature and the average temperature is small or equal than 10, then I want the value to be nothing special. So I want to point out that this might also be kind of feel a little bit unfamiliar because here I'm putting in a number. What is the, oh, okay. So I'm putting in a number, but the value is actually a character, right? So, sorry, I didn't copy the right thing. Okay, so I want this. Okay, it refuses to just copy the thing that they wanted to copy. So this is the code. So if I now say exceptional day, and so what's today? So today is like, I think it was like 29, so not actually exceptional. And then the average now is probably like a 27 or something in July. So what's going to happen? So what's going to happen is the value of this depending on 27. So the value of this expression is going to be maybe exceptionally hot or exceptionally cold or nothing special. Right? So if I run it, the value of this is nothing special. So that's a little bit weird if you're just used to math functions, which take in a number and then spit out a number as well. But it shouldn't be that weird, right? Because, well, why couldn't the value of a function be nothing special? It can, right? So here's my attempt at tracing it. So I'm saying, okay, so let's say the current temperature is 10 and the normal temperature is 25. So if I substitute it in, that is kind of what I'll get, right? So I'm substituting in 10 and substituting in 25, and I have this expression. So to compute this expression, well, the first thing that you need is you need to figure out what this is. How do you do it? Well, again, you just plug it in and you expand it. So here, after it's my abs minus 15, well, this is going to be the part where we plugged in my abs. So we just expanded it. What does my abs minus 15 mean? Well, it means this, right? And then what does this mean? Well, this is false, so this means that the value of this whole thing is going to be minus 15, because it's not true that minus 15 is greater or equal than 0, so that means that the value of this thing is minus 15, which is 15. So I did all of that, and then I intentionally made a mistake. So the mistake I made was I just said that the value is true, right? Because maybe I got confused. The idea would be, like, I'm trying to think of what kind of errors might people make. Well, maybe I got confused and I saw that I have, like, if my abs minus 15 is greater than 10, and then I said, well, that's true. The absolute value of minus 15 is greater than 10, so that must be that the entire thing is true. That's like not correct, because that's just a conditional and the actual value could be either this or this or this. And then you see that ChatGPT did catch that mistake. So, and then it even corrected me. And it corrected me correctly. So it says, okay, so this is like this, and then this is true. And then we are going to try to evaluate this. So 10 greater than 25 is false, so it's this. So that's the correct expansion. And then here we have if false exceptionally hot, else exceptionally cold. So the value of this is exceptionally cold, which is what ChatGPT says. So I don't have any TAs, so ChatGPT is going to be your TA. So the first exercise that I'm going to give you is step through this function. This function will give you like 2 or something. And then I can't mark you, however ChatGPT can. So what you will submit is a transcript of your conversation with ChatGPT, where the last thing that ChatGPT should say is, okay, now you're fine. Okay, now you could probably fool it, but at the end of the day, you'll be only fooling yourself if you do that. So, you know. So that's the concept. I was kind of playing around with it today. I think it works, but we'll see if it works for you. So I think the way in which it would not work is probably it's like easy to just BS ChatGPT into saying, okay, you're fine, just leave me alone. But although the thing about ChatGPT is it's extremely patient in my experience. So like, I used to just annoy people on the internet, and now, like, whenever I feel like annoying someone, I just talk to ChatGPT. So I do recommend that you buy ChatGPT 4. So that costs, I guess, like 25 Canadian dollars a month. I think very much worth it. GPT 4 is much better than GPT 3. So if you just tried the free one, you don't know what you're missing. I think kind of as engineering students, like well worth the investment to just kind of understand what's the state of the technology, just to understand the state of technology. I think it's like very different. All right, let's see what's going on in Discord. Yeah, okay. Were there any questions that were not answered? Is the logo broken or something? Oh, okay. Yeah, no one noticed it until now. You're right. It says 180. And it's been like a year. But I have made like the new icon, and as you can see, I was extremely productive today, and I even put this icon here, which was kind of annoying to do. Yeah. So okay. So are there questions that, because I don't really want to scroll up, so like if there's like burning questions in Discord, please like retype them. So yeah, so ChatGPT is gonna be inconsistent. So it's actually like surprisingly consistent, I would say. But technically, like if you ask, is it consistent or not consistent? Well, the answer is not consistent. I'm actually surprised. Like you try it multiple times, and usually it phrases things like in a very similar way. Yeah. Okay, so I think what we're doing is like we're taking a break until 8:20, and I'll briefly explain delayed evaluation. It's really like a third year topic, so if you're so I'll kind of explain it, but it's not going to be kind of a super detailed explanation. So basically what I'm saying is, how do you evaluate a function like that when you plug in current temp and average temp? So you might say, so there's kind of several options. So one extreme is called eager evaluation. So this is really advanced material. Like if you haven't done programming a lot, that's not going to make a lot of sense. So there's eager evaluation, and there is delayed evaluation. So eager evaluation means compute whatever you can as fast as you can. So in particular, that means that if you see, oh, I can compute current temp minus average temp, you just compute it right away. And then you plug that into MyAbs, right? So sometimes it's useful to not compute stuff right away and to say, I'll compute it when I need it, if I need it, right? So here, like it makes sense to compute current temp minus average temp when you know what the value is. But you might imagine a situation where the function myAbs actually doesn't ever use the parameter, right? So you might have something, so it's not that weird. So you can have like a function like f of x is equal to 1, right? And then, so this is kind of a toy example, but this is kind of the motivation, right? So if x is extremely expensive to compute, but actually at the end of the day, it turns out that you didn't need it. It's a shame. It would be a shame if you computed it and wasted all this time. So delayed evaluation kind of tries to take advantage of it. So if it turns out that you don't need this value at the end, it'll never be computed, is the idea of delayed evaluation. So one option is you say, okay, I'll just keep track of the fact that this is current temp minus average temp. And then if I ever actually need the value of this difference, then I'll compute it. But just because I'm sending it to a function doesn't mean that I need the value, because this function might not be using this value at all. So that's kind of the idea of delayed evaluation. Yeah.
Is it just used maybe to save memory?
Well, like runtime, right? So so memory, in fact, would, well, I mean, sometimes it could save memory. Sometimes it could use up more memory than otherwise, because you keep track of the entire expression instead of the result. Sometimes the result is huge, so it might save memory if you don't compute it. Yeah.
So we can just understand in a way that even though it's in an if statement, and the if statement is not going to get triggered, it still computes the thing inside the if.
Well, I mean, like the if statement knows that it needs this, and this expression knows that in order to figure out whether it's true or false, it needs the value of this. But when you just have this, you don't necessarily know that my abs cares about current temp minus average temp. Maybe my abs always returns 0. Right? So maybe it's this kind of situation. So that would be kind of just on a pure computation. So in practice, where this is used a lot is when you're querying a database. So in general, if you're working with a large database, it might be very expensive to retrieve data from it. And you might have a whole bunch of things that in principle can influence the result, but you want to say, I'm not actually going to go into the database and actually retrieve the value, which is very expensive, unless I actually know that I definitely need it.
So we just go back to my abs function to check if it's necessary.
Well, so you can't really check. So you can't. So I mean, sometimes, but usually you can't really check whether it's necessary or not. So what you're doing is you're just going, okay, like what does my abs do? And then you say, oh, it does this. Okay, I definitely need to know what x is. So at that point, you might compute the minus. Right, or it might be that my abs just so my abs could even look. So this is kind of, why is it not working? So this is kind of a silly example, but maybe my abs does something like very silly like that, where it says, oh, like compute me a y that's 2 times x, and then I don't care, actually the value is 10 after all, right? So you might have something like this, and then once you get to the 10, you say, well, I guess I didn't need the x because I'm done here. So to be clear, R does not do that by default. In some situations, especially when you're querying a database, that kind of thing might actually happen. And there are ways to kind of say, I want eager evaluation, I want not eager evaluation. Yeah.
What is the advantage for eager evaluation?
You mean like why not always do delayed evaluation?
Yeah, why not always
Yeah. So here it's better to do eager, right? Because it's better to just, because you need to compute it anyway, so it's better to just compute the one value that compresses the information that you need, and then just pass just that one value to the function. In principle, you have like functions, using functions. It might, like the thing that you're passing, the expression might grow quite fast. So that would not be good.
Oh, so it's basically I just compute the value and then store it as constant for the rest of the function. Right.
So yeah. Okay, what are people saying in art? Yeah. So that's so again, kind of if you're just a beginner, you shouldn't be thinking about this. I said like just listen to this if you already know. But yes, Arnav is right. I was doing kind of delayed evaluation because that's the process that kind of makes sense if you think about it as just substituting algebraic expressions into other algebraic expressions. So I was kind of, well, I should say, so I was kind of doing eager in a sense of if I have an arithmetic expression, I immediately compute it. Yeah. So how does R know? So everyone just so R by default does eager. So like you can have like fancy optimizations that somehow decide whether to delay or not. In general, it's eager. If depending on what you use to access databases, sometimes it's delayed by default. So, all right. Okay. Yeah. So I said we're stopping until 8:20. So I need to like rest for 3 minutes, and we'll start in 3 minutes. So 8:22.
Unfortunate people are but no way I can put is that so? No. Is that even in this? The small way. You use small way? I want to change it. I like that now. Keyboard.
And it doesn't have something on it.
I know, but it looks like my keyboard. They're similar.
But they have several contacts. The rest are basically,
Yeah.
so
Which hearing is this?
and also some other things. What the other stuff?
She got like a bigger keyboard.
Yeah, should have.
The
Mine's on
just the gaming laptop.
Yeah, this one's very disturbing.
You code a lot? You code a lot? Is that by PC with good specs?
Like, you can do C40.
What's your specs?
4080
Down.
13.
i9.
Yeah.
What the?
I feel like i9 sounds more expensive than i9.
Yeah, I know, but it's still 8. Can pick.
i9 is like 12K. Oh, $1,000.
Yeah, if I can pick, I'll just pick i7. 13 generation.
How much is that?
It's really solid.
That's cheaper.
35.
Bro, i9 is so expensive.
Yeah, I know.
I tried to buy one for 5K.
Okay, yeah. I mean, no one's worse than if you know, like, different.
I'm not trying to buy i9.
Do i7, 13 gen, i7, very good.
Yes. I recommend a coffee crisp. Nice.
Yeah, there are so many labs, they just had to replicate it and they all didn't replicate something.
But the technology is true, right? They managed to.
No, it doesn't have any superconductivity. Oh. Like, they just think
Yep.
this is a very weak magnet, and it's all superconductivity. They just did the evaluation at 329 today, and they said they didn't replicate the
Why is it this way called like a hot metal?
No, it's not hot metal. It's below 60 Celsius. It's set to thing wrong. So like below 60 Celsius, it's superconductivity. But PG.
If you can find like a room temperature superconductivity material, that's would be.
That's room temperature. The thing is, like, oh wait, no. It's actually from allergy chapter. No, never mind. This guy's like saying everything wrong.
Okay, all right, we're back. So I want to do kind of when to use cat, when not to. And I'll do kind of another example along the way. So I'll do a function called emotional state, and that will depend on the mark. And like we already did an example like this, and you probably have some personal experience with that. And then yeah. So okay. So something like that. Function. Oh, sorry. The other way. And this is mark. Okay. So something like that. So this is a function the same way that square is a function. Again, I can just say something like emo state 96, and the value of that is okay, right? In the same way that the value of square of 5 is 25. So if I just run this, so this is my program, right? So I have my function, and I say emo state of 96. I don't get any output. The reason I don't get any output is because so when I type stuff here, even if I type like whatever a number, it just says, okay, you just typed in this number. When you're running a program, if you say this, well, this doesn't print anything because you're just defining a function, you're not running it. Here, you are using the function emo state, but you're not telling the computer now print emo state of 96. You're just saying emo state of 96. That's the same as saying okay. You say okay to R. It doesn't care. It's fine. Because you didn't tell it what to do. You just enter the value. So on the other hand, if you say cat, whatever, meow, that will say meow, right? Because the cat is saying to the computer, print me something to the screen. So in the same way, so this I'll just comment out. So if I say like cat emo state 96, that will say okay. I'll comment out meow. So this action is referred to as commenting out. So making something comment so that R will ignore it. So that will now just say okay, because R will plug 96 in, will do the computation of what emo state of 96 is. Turns out it's okay, and then we print okay. Right? So you could have another kind of function. We won't write this kind of thing pretty much ever in this mini course. In 180, 190, sometimes yes, you would. So here, so I'll call it like cat emo state, which this is like a whole Tumblr thing. And here instead of saying hooray, I'll say cat hooray, and here I'll say cat okay, and here I'll say cat panic. So now if I run this, that will, I have an okay here too, so that will print panic. So the reason is that when R sees cat, that's an instruction to print something. So we won't usually do this, but it's possible to do. So anytime, anywhere you say cat, if in the process of computing the function R encounters that, it'll print. So generally in functions, we'll just never do that. So you should basically never say cat. inside the function. Cat is just for outputting whatever is the final result of the computation. But that's possible. So all right. So there are other implications here. So if I say meow is emo state, something like that, if I run this and then I say what's meow, meow is going to be hooray. Why is that? Well, that's because the value of emo state of 98, if you plug in 98, 98 is greater or equal to 98, so this is true. So the value of this whole thing is going to be hooray. So if I say, take this, which is hooray, and put it in meow, then the value of meow is going to become hooray. Right? And you see it here as well. The value of this variable meow is hooray. Okay. On the other hand, if you say bark like this here, and you run that, so what's going to happen when you compute this, because R sees the cat here, it'll print the panic, but the value of dog is not panic. The value of bark, sorry, is not panic, it's null. And the reason is that this has the effect of that. This tells R print panic right away. But the value of this is not panic. The value of this is in fact nothing. So if you're saying cat emo state of 50, that will have the effect of printing panic. But the value of this is not going to be panic, it's going to be null, and that's what's going to get assigned to bark. Now, in practice, in this course, we're just never going to say cat anyways, because like if you're doing R, you're basically processing data. You probably don't want to output something to the janky console anyway. That's like, we're just doing it for practice right now, and we'll stop doing it pretty soon. But just so you know, for the future, that's kind of the distinction. So, okay. So that's that. And now I want to do vectors. So a vector is an ordered collection of elements of the same type. So for example, you can have like 4, 6, 7. You can have like dog, cat. So they do have to be of the same type. It can be true, false, true, true, something like that. So this will have this value. This will have this value. So dog, cat. This will be true, false, true, false. So just a bunch of elements. You can assign it to a variable. So if I say v is this, and I run it, so again, to run it, Control Enter, then v is this logic vector whose value is true, false, true, true over here. So you can access the first true using v1. You can access this false using v2. This is true, and the fourth element is true. So you can access elements of the vector like this. Yeah. No. Yeah. So like this. So 1, 2, 3. Okay. So you can do all sorts of things with vectors. So we'll do kind of a more low-level version of this where we actually do the things that I'm just going to show you how R does automatically for you in Python later on. But for now, it's just like this. So if you have a vector like this, you can say sort v, v. And the value of sort v is the sorted version of this vector. So I can store the result. So I can say sorted v is sort of v. And now sorted v is going to be minus 52 to 4. So note that v is still 2 minus 52, 4. So in the same way that if you have like x is 5 and then you say squared x is square of x, well, x is still 5 and then squared x is 25, right? So this is, again, a function. And again, you can think about it as just a mathematical function. You give it a bunch of numbers that are not sorted, and what it does is it gives you the sorted version of the vector. Okay. So you can compute the length of the vector. So the length of v in this case is 4. So that means that it has 4 elements. So the 2 minus 50 to 4. So if you have a vector like this, where you have repeated elements, you can have another vector that's just the unique elements. And that's not this vector. No. What's going on? Oh, distinct. Not distinct? Okay, I'm confused. No, like unique should work. I don't know what this problem. Oh, it is unique. Never mind. Okay, so here, yeah, it was my problem all along. So here you have repetitions of 2's, and you see that you do unique. So it turns out to be useful when you're doing data analysis sometimes. So that just gives you the unique elements. Sometimes you want every element but in sorted order, and you can of course combine the functions, right? So you can say sort unique v. So this will give you a vector that has one copy of each unique element in the vector. And that if you want to get them in sorted order, you just say, well, get me unique of v, and now I'll give it to sort, and so sort will sort it. So you can combine this in the same way that you can do like x plus 1 squared, right? So how do you do it? Well, first you do x plus 1, and then you square it. So how do you do it? How do you do it? How do you do this? Well, you say, get me the vector of the unique elements, and then now that I have it, I'll just sort it. So that would be like this. You can have the maximum and the minimum as well. So I can, for example, have max v. So can I do max without having the max function? Well, yes, right? Because if you sort and then you get the last element, that will be the max, right? So if I want my max, what I can do is I can say, okay, so if I sort the vector, this is going to be the sorted vector. And now I want the last element of that. How do I get the last element? Well, I have my sorted vector. And if I go to element number length of vector, that's my max, right? So that's because, like, imagine that v is whatever, 5 to 10, 2. And then we say sort of v is going to be 2 to 5, 10. So that's just the sorted version. And then length of v is 4. So that's just the number of elements. And then if you say, get me the fourth element of this, well, that's going to be the maximum. Right? So that means, again, if you want to do my max and then give it whatever, you can, right? So what this is going to do, let's trace it again. or the step. So I'm using trace and step interchangeably, which people do. I'm trying to just say step, but if I slip up and say trace, I still mean step. So what does this mean? Well, we need to substitute v into this, right? So this is like this, and we'll just substitute this in instead of the v. So now this is going to be C, and then this is just the sorted version, so 2, 3, 5, 5, 10. And length of 5, 2, 5, 10, 3 is 5 because there is 5 elements. So that's going to be like this. So this is a vector. This is saying get me the 5th element of this vector. So get me the 10. Okay. Okay, let's check Discord. Okay, okay, this is just chit chat. Okay, all right. So, all right. Are there questions here? All right. So, okay. What else do I have? Oh, logical values. Yeah, okay. So, okay. So, two more things, I guess, that I'll do today is logical values and maybe using logical values to operate on vectors. So, we already saw logical values, right? So, we already saw stuff that's kind of like this. So, I can say x is 10 greater than 5. So what is x? Anyone?
True.
Yes. So 10 greater than 5 is a logical expression. It's either true or false. Happens to be true. So this is saying evaluate this. This is true. And put it in x. So I run it. And now x is true. So in the same way that you can operate on numbers to say like 2 plus 5, you can operate on true and falses. So arithmetic operators are like plus and minus and times and so on. Well, not so on, it's just like divide and that's it, right? So in the same way, it's called Boolean or logical operators. So those are usually kind of the ampersand, and this is called and the pipe, and this is called or. So in the same way that you can say that like 1 plus 3 is 4, you can say that true and false is false. So it works kind of like English. So if I say I'll get a 98 in ESC 180 and I'll get 100 in Physics 180, if one of those is false, then the whole thing is false. Right? And we can kind of write it like this, right? So like let's say ESC 180 is 98, and then Physics 180 is a mere 97. So I forgot what I said, but like ESC 180 is equal to 98, and Physics 180 is equal to 100. That is false. Why is that? Well, because this didn't define it. So this is true, and this is false, and then the entire thing, so true and false, is false. So I'll give you the rules now about how it operates, but you really should be thinking about it in English, right? So true and true is true, and then if there is a false anywhere, then it's false. Right? So that's like that. So the only way that that something and something is true is if both the left and the right operands are true. So false works the other way. So false or false is false, but everything else is true. So if there is at least one true in the expression, then the whole thing is true. And again, if you think about it in English, so if you say, I'll get an A plus in ESC 180 or in Physics 180, then if you didn't get an A plus in either, then that's a false statement. But if you got an A plus in one of them or both of them, then it's true. There is a little bit of a disagreement between English and kind of coding for specifically this kind of thing. So you might say that in English it's a little bit ambiguous, if not outright false, that if you say, like if you got A plus in both and you say, I got an A plus in ESC 180 or Physics 180, people would usually understand you to be saying, I got an A plus in one or the other, but not both. Right? In R and in Python and in C, it's not like that. So in philosophy, or in philosophy of language, I guess, and in computer science, so people use the terms exclusive OR and inclusive OR, I guess. Yeah. So like inclusive is like less usual, exclusive OR is the usual. So that's like the English OR. And this is like R's OR. Right? So, and this is the non-exclusive OR. Right? So this is saying if the left operand and the right operand are true, then the whole thing is true as well. Right. So that's the only real difference between kind of English and R is this particular case. So, okay. So let's do, I want to save like my favorite example for this for ESC 180. So let's do just, so what's a good example of OR? So maybe I want to say, well, so maybe I want to get ice cream if either it's very hot or I have a lot of cash, right? So I'll say, so cash is greater than $200 or temperature is greater than 30. And then maybe I have like $50, and maybe the temperature is 31. So if that's the case, well, get ice cream is going to be true, and that's because temperature is greater than 30. If both of those are false, so I'll make the temperature 29, I'll keep the cash being 50. So now get ice cream is false. Why is that? Well, because cash greater than 100 is false, and also temp greater than 30 is false. Okay. So why would I need this? Well, again, like for now, we're just doing a toy kind of example. So maybe I'll just write like a thing quickly. So if get ice cream, So here again, so if I get ice cream, depending on how much cash I have and what's the temperature, then either it'll print yum or yuck, right? So in this case, yuck. But if I get a little bit more money, then that's going to print yum. Make sense? So that's the basic of it. And of course, there's going to be not a lot of practice for this in this mini course, I think, but there's going to be a lot of this kind of thing in ESC 180, ESC 190. Kind of the rules are simple, it's just you have or, you have and, you have or. It can get complicated if you have very complicated logic because you need to do something complicated. In data analysis, not usually kind of something that gets extremely complicated. So you also have not. So not true is going to be false. So similarly, the value of something like this. So 5 smaller than 4 is false. So that means that not false here, the value of this is going to be true. All right. So, okay. So what does turn out to be very useful in data analysis is operating on vectors of truths and falses. So here's something that you can do in R. So you can do something like 5, 2, minus 1, 1 greater than 0. And what that's going to do is it's going to apply 5 greater than 0, 2 greater than 0, minus 1 greater than 0, 1 greater than 0 to every element separately. And it's going to give you a vector of truths and falses where this true corresponds to 5 greater than 0, and this true corresponds to 2 greater than 0, this false corresponds to minus 1 greater than 0, and so on. So something you can do with this is something like this. And this is maybe makes more sense to just think about it as like a pattern than trying to logic through it. So you can say something like v at v greater than 0. So if you give R the vector and then a bunch of truths and falses, what R is going to do is it's going to select the stuff that corresponds to truths and omit the stuff that corresponds to falses. So v at v greater than 0 is going to be 5 to 1. And that's because the 5 got selected, the 2 got selected, the minus 1 did not get selected because it corresponded to false, and the 1 got selected because it corresponded to true. You can do something with ands and ors. So let's say that I want to select elements in V that are between 0 and 3. Right? So one way to do it is to say I want the elements at V which are greater than 0, or I guess depending on whether you mean inclusive or exclusive of 0. So greater than 0 and also smaller than 3. So if this is V, then V greater than 0 is like this. So true if it's greater than or equal to 0, false otherwise. V smaller or equal to 3 is like this. So false if not smaller or equal than 3, true otherwise. And then if you say this and this, what's going to happen is we're just say is this true and also this true? Is this true and also this true? Is this true and also this true? And so on. And only make it true if both the left and the right are true. So if you look at V greater or equal than 0 and V smaller or equal than 3, that's going to be like this. So 5 is greater or equal than 0, but not smaller or equal than 3, so that corresponds to false. Another way of thinking about it, true and false is false. 2 is both greater than 0 and smaller than 3, so greater than 0, smaller than 3, true and true is true. Minus 1, not between 0 and 3, 1 is between 0 and 3, so you get this. So now you're saying I want to select the elements V where this is true when it's both greater or equal than 3 and smaller or equal than greater or equal than 0 and smaller or equal than 3. So you get 2, 1. So that turns out to be sometimes useful. All right, I'll go check Discord. Does R not have XOR? So the thing about XOR, so I always, yeah, and people answered. But the thing about, so XOR would be the exclusive OR. And, okay, I'll spoil this. I'll ask you again and see if you remember in ESC 180. So the thing that people don't realize is that XOR is actually the same as not equal, right? So XOR would be the exclusive OR. So what does exclusive OR mean? So exclusive OR means like true. So people sometimes write it like this, not in R. So true and true is going to be false, and also false or false is going to be XOR false. I'll write it as XOR. So this is more advanced material, but if you're interested. And then F XOR T is so that's XOR. So that's like the English OR, right? So if I say for dessert I'll have lunch or I'll have ice cream, in English you would understand it as the exclusive OR, where I was lying if I didn't have either lunch or ice cream, and I was also lying if I had both, right? So that's like that, where it's only true if either it's T and F or it's F and T, but not if it's both are T, both are F. And as it turns out, if you just so if you have two booleans, so two logical values like trues and falses, if you just say B1 is not equal to B2, that's the same as XOR, right? Because what XOR is saying is they're not the same. If they're not the same, then it's true. If they are the same, then it's false. So that's why technically you don't really need XOR that much, because it's just not equal. All right. Other questions on Discord? How is this not 3? So XOR is not plus, right? So basically, usually in most programming languages, like you shouldn't say XOR 1, 2 anyway. But usually what happens is anything that's not 0 gets interpreted as true, and anything that's 0 gets interpreted as false. So XOR 1, 2 would be interpreted as XOR true, true, which would be false. Can our vector hold null values? Yeah, they can. Yeah. But for the expression greater or equal, there is 3 or 0 elements, then it wouldn't get the numbers in between 3 and 0. Well, like it depends on what you mean by like between. So I made it so that between 0 and 3 means like including 0 and 3. Well, so null is not the same as numeric, so you can't have. So you can't have that. What's the difference between print and cat? Like for practical purposes, there's no difference.
I think print fits on a different line.
Say again?
I think print fits on a different line.
Yeah, I mean, you can make cat. I think with optional arguments, you can make cat do that as well. It's just about like the default. So I think it's got to be that append means, oh, that's for files. Fill. Yeah, so yeah, I can play around with it, but like again, like I don't know because like you wouldn't use it in R anyways. So yeah, all right. Other questions? Yeah, again, like yeah, this is so XOR is not like an R thing. I just had to write it somehow. Yeah, no, yeah. All right. Yeah, so vector is only the same type. Yeah. All right. Questions in the audience? All right. So I'll figure out the schedule. So I think the 2 times a week kind of works. Maybe I'll switch to Monday. I'll try to get us. So I like this room, but I'll try to get us the room like in the old like university college building, just kind of so that you have the experience of being there, which you might or might not get when you're in engineering. Like most of your classes are going to be here. And it kind of makes sense because you have a lot of classes and they try to schedule everything in the same place. And also it's near my office, but yeah, I mean, I think it's cool to have like the one class in the university college. So we'll try to do that. Yeah.
Can you add elements to a vector?
Can you add elements to a vector? I mean, you should. So in general, kind of the philosophy of this class is we don't change values of variables ever. So you can certainly do something like vector is like 1, 2, 3, and then you can say this is not really adding an element to a vector because this is making a new vector and then putting it back in V. But it kind of probably answers your question, which is yes, you can do this. All right. Whether you can mutate a vector in R, I'm, to be honest, not sure. Again, you shouldn't do it anyway. Yeah. So mutate means like, so here you understand the distinction, right? So, and maybe again, like if you're just here for the introductory stuff, this is probably a little bit too early for this discussion. But this, so here, like it looks like I added a 1 to V. Really, I didn't add a 1 to V. Really what I did is I made a new vector, which was the old V and then 1 at the end, and then this new vector I put back into V. Yeah.
So would that be also like, would that also create 2D vectors?
Well, as you see, no.
Okay. Like if the other one is also.
No, it just sticks everything together. It's gonna be one dimensional. Yeah. So if you want a matrix, that's something different. So like if you want a matrix, you just make a matrix. So yeah. All right, but we are not going to do matrices in this class. You can, if you like, have a vector of matrices, but a vector is just a one-dimensional collection of elements of the same types. All right, have a good night. I'll schedule something for next week, tomorrow, and I'll let you know. Thanks. Bye. Thank you.
Nice place, you know. What would I do at home? They go there? Where? Where though? Thank you, Professor.
Thank you. Bye.
I'm going to Waterloo.
Professor, how do you say your name?
Gerjoy.
Gurjoy.
Gerjoy. That's good.
Thank you.
Thanks.
Yeah, I think I can.
Hi, do you have like in-person lunches every week?
So I'm actually gonna be away from Toronto, like hopefully in 2 weeks' time. So definitely not then. I think I'll do like maybe one lecture in UC just for fun, in University College, and yeah, we'll see. Like I'll also see how many people want to actually show up, which so yeah.
Thank you so much for doing
Yeah.
this. by the way.
Thank you.
Thank
Yeah.
you so much.
Yeah.
I like your jokes.
I try very hard.
I'll see you next time. Have a nice day.
Bye.
Thank you, Professor.
Bye.
I'm going home. I'm gonna ask you about something. I said, you guys want to bring it?
Yeah.
So I was a bit confused because I'm not really done coding before. I
Yeah.
just started learning this summer. But like, what's the curly bracket?
Yeah, so basically, we've seen it in two contexts so far, right? So
The if statements. And then
that's right.
and then-
Yeah. So we have one kind of situation where, mm,
But it's like,
so something like that. So this is just saying, okay, like the value of this formula is either this or this, depending on whether it is greater than b or not, and then those values have to be enclosed in curly braces.
so else has to be closed in curly braces.
Yeah, like also all the curly braces. So like the way I would think about it is the value here is enclosed in curly braces.
Yeah, that's what I thought.
Yeah.
I was kind
Uh,
of confused with why else? Because it doesn't. You're not ending the statement at.
Well, I mean, like this is just so in math. So in math, I don't know if you saw it. So sometimes people write stuff like this, right? So like a is like 1
Oh yeah, when you
if
write, yeah, like a.
x
yeah.
squared is greater than 5 and 0 otherwise, or something like that, right?
Yeah.
So this is just another format for writing exactly this, right?
Okay.
And then kind of this thing and this thing, according to the rules of our syntax, have to be enclosed in curly braces. That's all
It's
there is
like,
to it.
it reminds me a bit of Java.
Yeah.
If that makes sense.
Yeah, and it is the same, kind of the same way in Java. So in Java, actually, technically, if it's just one line, you can omit the curly brace. But I think maybe not
So
in
you
Java.
need the
No, so like this is very similar to what you would see in Java. Right.
I'm not done Java.
Yeah.
I don't know what it looks like.
Yeah. So, but basically, yeah, like all there is to it is like according to the rules of syntax in R, like this thing and this thing have to be in curly braces. That's all there is to it. And then with functions, it's again the same. So like a function is written like this, for example, right? So like this is like the math function, and then the R equivalent is this, and it's again the same, like the x squared here, just according to the rules that must be in curly braces. So maybe it would be, so kind of this is how people usually write it. Technically, R doesn't care if you write it like this. So that's valid as well. So maybe that makes it kind of makes the analogy more clear. It's just that the rule is it has to be in curly braces.
And then there was kind of another instance where you said my cat, and then you did it equals to like a function of x, or function of Mark. And then you kind of in the end of the after you define the function, you put my cat and then you put brackets with round brackets.
Right.
So when you define the function at the beginning.
Right.
So like you just define it, so then you can input any argument into it.
That's right. That's right.
So
So it's a little bit different from so basically the way to think about it is the highlighted thing. It's this kind of thing, right? So in the same way that this whole thing is 1 or 0, right?
Yeah.
This whole thing also is just something, kind of whatever it is according to what's written.
Okay. So like, if you read it, we'll read it out. So,
Yeah.
Okay.
Yeah.
That makes sense. Okay, thank you.
Sure. Right.
Are there going to be any more in-class lectures?
So yes, I think I'll book at least the one in University College next, if I manage to, next week, and then probably not anymore because I'm going away. Yeah.
Okay. All right, thank you.
Sure. Bye.